Hi everyone, my name is Santiago, and today I'm going to talk about something that might sound complicated at first, but it's actually all around us: differential equations. Even though most people don't realize it, differential equations are everywhere in engineering, nature, technology, and even daily life. In this video, I'll explain what they are, why they're important, and how they make our world work. So, what exactly is a differential equation? A differential equation is a mathematical equation that relates a function with its derivative. In simple words, it shows how something changes over time. For example, when we describe how a car accelerates, how a population grows, or how temperature change in a metal. All those processes can be modeled using differential equations. They help us understand motion, growth, decay, and any type of change happening in the real world. In engineering, differential equations are essential. They help engineers model systems, predict behavior, and design solutions. For example, mechanical engineers use them to analyze motion and vibration in machines, cars, or robots. They can calculate how fast an object moves or how forces affect it. Civil engineers use them to study how buildings or bridges react to weight, wind, and even earthquakes. Without differential equation, it would be impossible to design safe and stable structures. Electrical engineers use them to model current and voltage in circuits. They describe how electricity flows through wires and components over time. And chemical engineers use them to model chemical reaction, heat transfer, and diffusion. This helps industries produce materials efficiently and safely. In short, differential equations connect theory and practice. They make it possible to bring engineering ideas to life. Now, differential equations aren't only used by engineers, they're also part of our daily lives, often in ways we don't notice. For example, they are used to model the spread of diseases like COVID-19. Scientists use a differential equation to predict infections rate and design better control measures. They also describe population growth, economic trends, and even how your phone battery discharges over time. When you check the weather forecast, those predictions come from massive system of differential equations that simulate temperature, pressure, and wind movements. Even when you listen to music or use your GPS, differential equations are working in the background, processing signals and calculating positions. They're truly everywhere. To conclude, differential equations are not just complex mathematical tools. They are the language of change. They help us understand, predict, and control the world around us, from designing airplanes and building to studying biology and climate. They allow us to connect mathematics with reality. That's why they're so important, not only in engineering, but also in our daily lives. Without differential equation, many of technology we depend on today, like communication systems, medical equipment, or transportation, wouldn't exist. So next time you see something working perfectly, remember there's probably a differential equation behind it. Thank you for watching, and remember, math is not just numbers. It's a way to understand the universe. Thank you. Goodbye.